Let's continue on looking at some additional examples using compound interest. Then we're going to talk about what happens if the interest is compounded continuously. And then finally, we're going to wrap up with how to find the APY, or the annual percentage yield. So let's start with Sally invests $5,000 at 7.25% APR compounded quarterly. How much is in the account after 18 months, and how much interest was earned? Well, in order to do this, we notice that we have compounded, right? So that tells us we're working with a compound interest problem. So that tells me I'm going to be using the formula that FV equals P times 1 plus R divided by N to the NT power. And so FV is the future value, how much is in the account after 18 months. So that's going to be what we're looking for. The P value is the 5,000, or the initial amount that we invest. 1, of course, is always 1. Now, when we get to R, notice that the R we are given is in 7.25% right now. So the first thing we have to do is change that 1/4, or that quarter, into a decimal by dividing 1 by 4. And we find that that's the same as 7.25%. And then to write that as a decimal, we're going to move the decimal point 2 places to the left. So we get that our R value in this case is actually 0.0725. Our N value, well, we're told it's compounded quarterly, so our N value is going to be 4. And then our T value, well, notice that this is 18 months, but remember, T is always given in what? In years. So we have to figure out how many years is 18 months going to be. So to do that, we come to the side and we say, okay, how many months are there in 1 year? There are 12. So 18 divided by 12 gives us 1.5. So our T value in this case is going to be 1.5, or 1.5 years. Now we can plug all of this into our calculator, and we get a final value, or a future value here, of $5,568.99. Now that answers how much was in the account after 18 months, but notice that we're also asked to find how much interest was earned. Well, remember, interest is always going to be the difference in the future value and the principal, or the FV and the P. So in this case, we're going to take our FV of $5,568.99, and we're going to subtract our P, or our original amount of 5,000, and we see that we get $568.99 as our interest earned. On his 18th birthday, Richard's grandmother gave him access to a savings account set up when he was born. The account earns 3% APR compounded monthly. If the account currently has $13,718.81, how much was deposited when he was born? So again, we see that it's compounded monthly, so that tells me I'm working with a compound interest problem. And so I know I'm going to be using my compound interest formula, which is FV is equal to P times 1 plus R divided by N to the NT power. So now we have to figure out what values have we been given, and what are we trying to solve for. Well, I know that the account currently has $13,718.81. So that's the future value. That's not how much they deposited originally. That's how much is in the account now. So the FV is going to be $13,718.81. The P, the amount that they originally deposited into the account, is what we don't know, and that's what we're looking for. 1, of course, is always going to be 1. The R is 0.03. The N is compounded monthly, so N is going to be 12. And the T in this case, well, if they deposited it when he was born and they gave it to him on his 18th birthday, then that would be 18 years for it to accrue. So again, notice that because we have values on each side, we are going to have to find all of this value and then take $13,718.81 and divide it by that value. And you're going to have to use your ANS key or your answer key on your calculator in order to keep this as a non-rounded exact number. And if you don't know how to do that, you can search online how to use your answer key, or you can also shoot me an email, let me know what kind of calculator you're using, and I can usually kind of direct you on that. So once you plug all of that into your calculator, you're going to get that P is equal to $8,000. So that means that they deposited $8,000 when he was born. So we've talked about interest that is compounded annually, semi-annually, quarterly, monthly, and daily. But what about interest that's compounded continuously? And that's exactly what it sounds like. When it's compounded continuously, that means it is compounded as quickly as it possibly can, over and over and over and over and over again. So we don't have a set number of compounding periods each year. Instead, we have to use a totally different formula for compounded continuously. And this formula is going to use E, which is what we call a constant variable, and it has an approximate value of 2.71828182884. We're simply going to use 2.72 in most of our calculations that we have to do by hand, but on our calculator we have an E key, and if we use the E key, then the calculator will take care of that approximate value for us. So you'll notice that everything else within the formula matches our previous formula. We have FV, which is still our future value. We have P, which is still our principal or the original amount invested or deposited. And then we have R and T, which are rate as a decimal and time in years. So that E is taking the place of the 1 plus N divided by R, and then we have it to the RT instead of the NT. So let's look at an example where we are using the continuously compounded interest formula. Find the value after 10 years of a $30,000 loan at 5% interest compounded continuously. So we see this word compounded, and the fact that it's compounded continuously tells me I'm going to be using the continuous compounding formula, which is FV is equal to PE to the RT power. Now we just have to figure out what is our FV. Well, we want the value after 10 years, so sometime in the future. So that's what we're looking for. Our P is the amount that we deposited or invested originally, which is $30,000, or borrowed, I guess, in this case. E, of course, is just E, because that is what we call the constant variable. And then RT, well, R is our rate, so 5% as a decimal, times T in years, which would be 10. So we can now put all of this into our calculator, and we get that the future value is equal to $49,461.64. And again, part of the key to being successful with this section is knowing how to use your calculator. So if you're still having problems with that, make sure that you reach out, get some help. Either look online or email me or stop by and see me during office hours or something so that you are using your calculator correctly. All right, let's look at another example where we're using compounded continuously. So consider a CD paying 4.1% compounded continuously. Find the future value of the CD if you invest $720 for a term of 500 days. So I know we're dealing with continuously compounded because it tells me compounded continuously. So that tells me I'm going to be using my continuously compounded formula. So FV is equal to PE to the RT power. Now we just have to figure out what each of these values represents. Well, FV, the future value, is what we're finding. P is the original amount that we invested. So it told us that we invested $720. And notice that when we get to R, we have 4.1%, so 0.041. But our T is not given in terms of years, it's given in terms of days. So we're going to have to write it in terms of years. Well, how many days are there in a year? There's 365. So 500 divided by 365 is going to give us the time in years. So we can either plug it into our formula like that, or we can come over here to the side and actually do 500 divided by 365 and punch that into our calculator. And when we punch that into our calculator, we get 1.36986 da 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 da. So we don't want to round. Remember, I talked about the fact that rounding can give us a slightly incorrect answer. So instead of rounding it, we could choose to simplify this by dividing both the top and the bottom by 5, or we can just plug it into our formula as it stands. And so it's really just a preference for you. Do you want to plug it in as 100 over 73, or do you want to leave it as 500 over 365? And either way, you're going to get the same answer. You just have to choose one or the other. So once we put that into our calculator, we get a future value of $761.60. The last thing that we're going to talk about in this homework section is APY, or annual percentage yield. And APY is actually only applies to compound interest, because in simple interest, the APY and the APR are the same. But if you think about what it means to have different compounding periods, if you have more compounding periods, then you're going to accrue interest quicker, and then you're going to be accruing interest on that interest. So even if you have the same APR of, say, 5%, if it's compounded annually, you're going to earn less interest than if it's compounded semi-annually, or quarterly, or monthly, or even daily. And so that's where APY comes into play. You are going to use not only the R, the rate, but also the number of compounding periods to determine what the APY actually is and which one's a better deal. So let's compare the following options. We have 8% compounded semi-annually. So we want to, excuse me, because it's compounded semi-annually, we're going to use our standard compounding APY formula. So APY is equal to 1, and remember, 1 is always just 1. Then R in this case is 8%, or 0.08, divided by N. Well, semi-annually has an N value of 2, raised to the second power, and then minus 1. So we plug all that into our calculator, and we see that the APY in that case is 0.086, or 8.16%. Now let's do the same thing for 8% compounded quarterly. And again, because we're still using a standard compounding period, we're going to use our APY formula of 1 plus, in this case, it's still, our R is 8%, or 0.08, but now our compounding period is 4. Plug all of that into our calculator, and we get 0.0824, or 8.24%. So you can see that even though the 8% was the same in both cases, the APY turns out to be a little bit different because of the number of compounding periods. In our next example here, we have a 7.9% APR, and we are compounding monthly. So let's see what we get when we use 7.9% compounded monthly. And you may be thinking, well, why even try it, because 7.9% is less than 8%. But it turns out just because the APR is less doesn't mean the APY will be less. So go ahead and pause the video here and plug the values in and see what you can get, and then I'll show you what I end up with. And then in our final example, you'll notice that it's compounding continuously, so we're going to use our APY for continuous compounding, plug in our value, and we end up with 8.